Introducing TRANSnet, the world's most advanced public transport priority software package, providing a revolutionary approach to managing and controlling public transport priority. Most existing public transport proprietary systems provide a basic and repetitive level of priority to vehicles at signalised intersections, even if priority is not actually required. They typically use detectors that are only actuated by special transponders fitted to public transport vehicles. They also require specialised installation of detector hardware at intersections. These are fitted at the intersection during installation, and once installed, essentially there is little opportunity provided for adjustment or fine-tuning. Moreover, if the detector is not placed far enough in advance of the intersection, a bus may become caught in a queue of vehicles, delaying its arrival at the installed detector and therefore creating further delays for the vehicle. TRANSnet revolutionises that approach. Designed to work with SCADs, TRANSnet uses real-time vehicle position data and map-based virtual detectors, together with powerful and flexible configuration data, to provide the most adaptable and versatile public transport priority system available today. This includes adjustable trigger conditions, priority escalation, and intersection restore to normal operation functions. So exactly how does TRANSnet provide these features? A vehicle status data feed is required, which supplies regular updates on bus position, schedule delay, vehicle stop data, specific journey pattern and route information. TRANSnet supports two different detector systems, queue detectors and journey time detectors. Queue detectors are generally used to monitor the length of time that public transport vehicles spend within a particular detection zone. Journey time detectors provide information on public transport vehicle journey times over a larger network area. Journey time detectors consist of two or more virtual detectors, a start detector and one or more corresponding end detectors. The vehicle journey time is calculated as the travel time incurred between the start and end detector zones. In existing systems, special physical detectors are placed a known distance from the intersection, usually close to the stop line. If there are queues that prevent the bus from arriving at the detector, the necessary priority simply cannot be provided. With TRANSNet's virtual detector system, it's easy to add detectors anywhere along the roadway and apply different priority settings to each. In this way, a delayed bus can make a request for a downstream intersection to provide additional green time to clear a vehicle queue that is delaying the public transport vehicle from travelling through the intersection. In TRANSnet, the operator decides the location of the detection zone and simply draws the detector on the map surface using the integrated design tools. Detectors can be created to cover a basic area or with complex shapes to cover unusual intersection approach geometry. Virtual detectors reduce reliance on hardware, are extremely adaptable and don't require expensive field installation and maintenance. Once the detector is created, the operator assigns certain parameters so that the detector knows about the correct approaches and the routes and journey patterns that will be managed by this detector. If existing journey patterns are known, the system can even automatically identify which journey patterns are available for use by this detector. Virtual queues are available to assist the operator to identify the expected operation and approaches that this detector will manage. If journey time detectors are being created, the associated linkage between start and end detectors is easily applied and identified. Parameter list data is created that contains the trigger conditions for the priority to be implemented. Logical and/or rules can be applied to engineer simple or complex trigger criteria conditions, and the system can automatically apply predetermined default values if required. Because of the flexible options provided by the system, priority can be requested to any combination of parameters for late-running vehicles, multiple vehicles in the same queue detector, vehicles that don't clear the detection zone within a specific time frame, multiple occurrences of long detection times, extensive journey times based on averages of individual vehicles, and much more. The heart of the TRANSnet system is the TRANSnet Priority Manager, which allows multi-level priority options to be applied, and each priority can automatically escalate to a more severe level of priority if required. Once priority is initially applied, a minimum time must complete before trigger conditions are rechecked, and if required, priority escalation then occurs. There's no limit to the amount of escalation steps that can be applied. For example, initial priority might be provided by giving additional phase time to an approach. This could escalate if required to change a split plan, increase a cycle length, then to provide a green wave, or to dwell one or more intersections if required. Using this adaptable operation, the exact level of assistance to provide vehicle priority is always applied. Trigger conditions are continually monitored. Once the trigger conditions are no longer met, the system can automatically introduce a cleanup procedure to revert the intersections back to normal operation, for example to remove any applied trims and cycle adjustments, etc. When a trigger condition is detected, the system can be programmed to control one or more intersections. For example, if a bus is detected behind schedule, rather than waiting for the vehicle to be detected at other specific locations before commencing further priority improvements, corresponding cycle length or phase times might be increased at intersections further downstream to proactively provide additional priority to assist to restore the schedule. Action blocking is also incorporated. Once a number of priority events applied at a location has been exceeded within a given time, further priority assistance can be blocked for a specified period. This allows road conditions affected by the priority to be returned to normal. Action blocking is selectable on an individual detector by detector basis. TRANSnet even includes a completely programmable simulator, which allows the operator to take historical data and apply different rules to evaluate and optimize detector placement and parameters. This simulator can also be set to operate at faster or slower than real time. TRANSnet incorporates a powerful and flexible scheduler that automatically applies predetermined parameter list rules to any virtual detector at any time of the day. This allows the operator to program priority for specific directions according to time of day, to enable or disable, or simply change the priority for one or more detectors, and to introduce special plans on weekends, public holidays, etc. The calendar scheduler is completely programmable and incorporates recurrency controls so that specific normal event parameters can always automatically be applied by a combination of weekday, certain day of the week, weekends, or for next specific number of occurrences, etc. TRANSnet even includes special vehicle tracking so that the journey path of any selected vehicle can be identified and monitored directly on the map display. All activities undertaken by TRANSnet are recorded to the database, and comprehensive reporting tools with search filters allow operators to review the operational status at any time. And most real-time actions are also recorded to a log file that can be assessed quickly and easily. Powerful performance recording and reporting functions are all part of TRANSnet's features. Comprehensive performance reporting on vehicle journey times and queuing times are also available and presented to the user via graphical and tabulated data displays. Multiple filter options are provided to allow examination of network performance by specific detectors, individual bus journeys, or overall fleet operation for a route. Once any report criteria has been defined, it can be optionally saved and recalled at any time, which is useful for undertaking comparative before and after performance measurements. TRANSnet introduces the ability to cover greater city areas and provides a dynamic visual representation of road usage by public transport vehicles. It provides accurate performance measurements of individual vehicles, specific routes and broader network operation. TRANSnet allows operators to see the actual performance of the system and request for priority, all in real time. The use of virtual detectors reduces reliance on hardware, reduces implementation costs, and provides absolute flexibility and adaptability. With programmable trigger conditions, priority escalation, clean-up tasks, as well as flexible parameters governing activation of priority, all controlled through a powerful scheduler, the TRANSnet system leads the world in active and adaptive priority for public transport. Independent studies have demonstrated a significant improvement in journey times for public transport vehicles when using TRANSnet. The TRANSnet system is flexible and adaptive. Its detectors can be located anywhere in the road network and can be individually programmed to provide priority for either general or very specific requirements. This includes priority to particular bus routes, schedule deviation, queuing time at a specific location, overall journey times, vehicle density in detection zones, and much more. It also caters for sensible sharing of other road users' requirements, providing compensation for other vehicle demands when needed. TRANSnet keeps public transport moving. Advantech Design has more than 30 years' experience in the computer and electronics industry, specialising in the development of intelligent transportation systems applications, both within Australia and for road authorities throughout the world. TRANSnet is the latest product in a comprehensive range of ITS solutions from Advantech Design. An extensive list of impressive features ensures that TRANSnet is the public transport priority management system for your traffic network.